Alright, so today we are going to be focusing on the Pythagorean Theorem, as stated. Unit 6, Day 1, our new unit. Our new unit is all right triangles. So this whole unit from Day 1 through, it's a long unit, Day 1 through Day 11, okay, is all going to be right triangles. All right triangles, okay? So, Pythagorean Theorem notes. Recall the Pythagorean Theorem, a squared plus b squared equals c squared, can be used to find the missing sides of a right triangle. Super important that we note we're always talking about a right triangle. Okay? If it's not a right triangle, you can't apply the theorem. It's got to be a right triangle to apply the theorem. If we have our legs are the a and the b. And then the hypotenuse is your C value. The A and the B are interchangeable, but that hypotenuse has to be the hypotenuse. Okay? You'll know it's the hypotenuse is because it is across from the right angle. The right angle points at it. And because the right angle is the biggest angle in the triangle, because together if they have to add up to 180, and I've used 90 here, that means there's only 90 to divide amongst those two. Somehow, in some fashion, so I could have one angle and 1 degree here and 89 degrees here, or 45 and 45. However you want to break up that other 90 degrees, they're always going to be smaller than this angle, which means my hypotenuse is always going to be the longest side. And then later we'll talk about these legs. Sometimes you have a shorter side and sometimes you have a longer side, and sometimes they equal each other. The legs are different, okay? But the hypotenuse is always the longest of the three sides. Okay? We're going to take our Pythagorean theorem and we're going to use it to create shortcuts for when we're looking to find the hypotenuse and when we're looking to find a leg. Because usually they're going to give you two sides and you're going to be trying to find the third side. Okay? So when I look at the first one, it says to find the hypotenuse. So we're going to solve for the hypotenuse, which is C. So I'm going to solve this equation for C. Right now C is almost solved for. It's all by itself, but it's being squared. And I don't want to solve for C squared. I want to solve for just C. So how do I get rid of the square? Square root. And if I square root the right side, then I also have to square root the left side, right? You can't just do it to one side. So on the left side, I've got the square root of A squared plus b squared, thank you. And on the right hand side, the square and the square root canceled out. So I end up with just C. On the right hand side, when I look at if I want to solve for a leg, we could solve for either A or B because they're both legs, but I went ahead and said let's solve for A. So I have a leg squared plus a leg squared equals a hypotenuse squared. We're going to solve for one of the legs. I just picked let's solve for A, which means I need to get A squared by itself first. So I need to move this plus B squared to the other side. How do I do that? Subtract it. Yeah, subtraction property of equality. So when I do that, I'm going to end up with A squared equals, because that goes away, C squared minus B squared. So now I've got A squared all by itself, but I want just A. So how do I unsquare it? Yeah, we square root, just like before. Just like over here. If I square root one side, I have to square root the other side. On the left side, my square root and my square cancel out. So I just have A. On this side, I have the square root of C squared minus B squared. So when I solve this for the hypotenuse and I solve this for the leg, I get similar answers. They're just a little bit different. So here I solve for the hypotenuse, and here I solve for the leg. And in both cases, I'm square rooting something. And then inside, I have a number squared Here I've got a plus, here I've got a minus, and then a number squared, a number squared. So really the main difference is the sign in here. When I'm looking for a hypotenuse, I'm going to be adding two sides that are squared together. And when I'm looking for a leg, I'm going to be subtracting the other two sides that are squared. Right? Subtract. So you square the two sides and square root the result. If you're looking for the hypotenuse, you add them. If you're looking for the leg, you subtract them. Okay? And if you're using one of our calculators, you can just put it all in at one time. Okay, so you don't have to, it's not a bunch of different steps. If you're trying to do this, I know some of you still just want to use your phones all the time for calculators. You have to square this number, get a result, square this number, get a result, add the two numbers together, get a result, square root that result. There's a lot of things you have to put in step by step, and then there's a lot of places to accidentally type a wrong number or make a mistake. Whereas on a graphing calculator, you can put that whole thing in at one time. Okay? Now, something important to remember is the order that we put these in. This says a squared plus b squared. Now they're legs, and the legs are interchangeable. So it's not going to matter what order you put these in over here. But over here, when we say c squared minus b squared, the c and the b numbers are not interchangeable, right? Because the c is the hypotenuse. That has to go in first. Your other leg has to go in second. So what I'll do so that I don't make a mistake is I just remember that the c is the biggest number. And so this big number has to go in first out of my two sides that I have. Over here, it doesn't matter if I put the big number or the small number first. So if I put the big number first over here, I'm going to get the correct answer. If I put the big number, I have to put the big number in over here first to get the correct answer. So what I do, just to make sure I always put the right thing in first all the time, no matter if I'm doing hypotenuse or leg, as a tip, I always put the bigger side first. You only have to do it for finding a leg, but it'll work for both. So just why not do it all the time, right? So you don't have to remember when I need to do it, when I don't need to do it. If you just always do it, you'll never go wrong. If you get it backwards, your calculator will immediately tell you, hey, you messed up. You're not doing things right. Your calculator will tell you. So I'll show you that in the example in a minute. All right, so when I look at these examples, and on this first one I'm trying to find C, and since we know C represents a hypotenuse, I know if I'm trying to find a hypotenuse, we said we're going to add inside our square root. I'm going to put the big number and then the small number. Don't forget you have to square them. So my big number here is 12 squared. My small number here is 5 squared. Here's how we're going to put it in the calculator. So in the calculator, this is on the home screen. I'm going to do new document. Don't save the old one. And a calculator. So I'm going to do Control X squared to get my square root symbol. See if I can brighten that up a little bit. And then inside my square root, I'm going to do 12 squared plus 5 squared. And my calculator will do all the math for me and tell me that the answer is 13. And done. The value of C there is 13. Okay. When you get a whole number like this, 5, 12, and 13, if those three sides all make a triangle, that's called a Pythagorean triple. So just as some extra bonus notes over here on the back cover of my thing, I'm going to put Pythagorean triple. A Pythagorean triple is just a set of three numbers that works in the Pythagorean theorem. The most common one that we see all the time is 3, 4, 5. Where 5 is the hypotenuse because it's the longest side. If I do 3 squared plus 4 squared, that's 9 plus 16, which is 25. And the square root of 25 is 5. Okay? So now we have another one. The next one we have is 5, 12, and 13. it's kind of nice to get to know the Pythagorean triples because as teachers, we like to use Pythagorean triples a lot because it gives you answers that are whole numbers, and so you don't have to worry about kids messing up rounding. So if you can kind of learn some of the usual Pythagorean triples, it sometimes makes your math a little bit easier. Okay? What's also neat is every multiple of these Pythagorean triples works as well. So if I do 3 times 2, and 4 times 2, and 5 times 2, 6, 8, and 10 will also work in Pythagorean Theorem. I could do 3 times 3, 4 times 3, 5 times 3. I could multiply all of these by 3 and get 9, 12, 15. That would also work. So you could infinitely keep multiplying and find Pythagorean triples. Okay? Same here, I could do 10, 24, and 26. Right? And you could keep going. Yeah, yes. Okay? All right. So let's look at this next one. On this one, am I looking for a leg or a hypotenuse? I'm looking for a leg. So B is a leg. So in my square root, I know when I'm looking for a leg, I'm going to subtract. So in my square root, I'm going to put a minus sign. Bigger number goes first. So the 15 goes first. The 9 goes second. Don't forget to square those numbers. If you don't square it, you definitely get the wrong answer. Okay? So the square root of 15 squared minus 9 squared is 12. So B equals 12. So this is another Pythagorean triple. 9, 12, and 15. So if you wanted to keep a list of them, you could come over here and do 9, 12, and 15. Which is really just 3 times 3, 4 times 3, 5 times 3. So it's a multiple of this original 3, 4, 5 Pythagorean triple. Okay? Next. Here's some more practice. It says find x. So in this problem, is x a leg or a hypotenuse? It's a hypotenuse, so x is a hypotenuse. So x equals the square root of, for a hypotenuse, do I add or subtract? Add. Put the bigger number first, so 8 squared and then 6 squared. Y'all do this one in your calculator. What do I get when I do the square root of 8 squared plus 6 squared? 10. 6, 8, 10 is a Pythagorean triple, which I think we already wrote down because it's 3 times 2, 4 times 2, and 5 times 2. It's a multiple of the 3, 4, 5 triangle. All right. The next one, are we looking for a leg or a hypotenuse on this second one? A leg. So x equals the square root of, am I going to add or subtract? Subtract. What number goes in first? 17. Don't forget to square it. And then 8. Don't forget to square it. So x equals the square root of 17 squared minus 8 squared is 15. So 8, 15, and 17, that's Pythagorean triple we haven't written down yet. So that's when you could add to your list if you want. 8, 15, 17. This is a Pythagorean triple. And then write all your multiples of that. Right? You can multiply it by 2, 3, 4, whatever you want to multiply by. Those will all be Pythagorean triples. Okay? All right, the next one. Am I looking for a leg or a hypotenuse? A leg? How do you know that's a leg? How do you know there's a 90-degree angle? We don't, right? We can postulate, we can theorize, we can assume that that's a right angle, but they didn't put a box there, And we know a lot of times our pictures are not to scale, so we are not allowed to assume that that for sure is a right angle. We don't know what this is. So technically this triangle, we can't find that third side. We can say it's between the difference of 16 and 34 and the sum of 16 and 34. It has to be somewhere between the difference and sum of the other two sides. We learned that near Thanksgiving. But unless we know that's a right triangle, we can't actually find x. But if it's a right triangle, then let's find out what x is. What do we need x to be for it to be a right triangle? Okay? So if x is the leg of a right triangle, then are we going to add or subtract to find it? Subtract. For a leg, we're going to subtract. What number is going to go in first? 34 squared, and then 16 squared. So x is what if we have a right triangle? 30. If the triangle is right. And that's if the right angle is where we put it, right? If the right angle is here and it's just really not to scale, then we'd have to do the whole thing again. Now, this is another triple, right? 30, 16, and 34, but it's just the double of this one, right? 8 times 2 is 16, 15 times 2 is 30, and 17 times 2 is 34. So it's just the double of this triangle, just twice as big, even though it looks like it's not twice as big. All right, the next one, am I looking for a leg or a hypotenuse? Hypotenuse. We have our right angle on this one. Oops, x equals. So am I going to add or subtract in my square root? Add. Which one's going to go first? 12. And then 9. So 12 squared plus 9 squared inside my square root gives me 15. And that again comes from the 3, 4, 5 triangle being multiplied by 3. X equals 15. Alright, normally in geometry when we come across a problem that doesn't have a picture, I tell you should always draw a picture, but on this one we don't really have to because it tells us we're looking for the hypotenuse. And I know when I'm looking for the hypotenuse, I'm going to what? Add or subtract? Add. I have my two legs are 8 and 11. Which one should I put first? 11. Don't forget to square it. The 8. Don't forget to square it. When I put this one in the calculator, 11 squared plus 8 squared, it's not a Pythagorean triple. This is our first one today that doesn't give us a whole number. What are we going to round to? How many places? 3 places, so that we're practicing for the AP test someday. So I'm going to have 13.602, because that 5 is going to bump the 1 up. 13.602. Okay. The next one, I would recommend drawing a picture. So for this one, a 15-foot ladder is resting against a home. So think about in your brain what it looks like to rest a ladder up against a wall, right? So we have the home, and we're leaning a ladder up against the side of the house. So it's going to look something like that. It's a 15-foot ladder. Where does the 15 go? On the ladder. It's a 15-foot ladder. It goes on the ladder. The base of the ladder is 6 feet from the home. So the base of the ladder is 16 feet from the home. Or sorry, 6 feet from the home. How far off the ground is the ladder? Now, you might look at this and go, how do I know that there's a 90-degree angle there? What if the house is like falling over? What if, all of these things. We are allowed to assume, and I never say that sentence, but we are allowed to assume that construction is done correctly, unless otherwise noted, when we're doing geometry word problems. So I get to assume that when they built that house, they really did do a good job, and it's coming up 90 degrees to the ground. Okay? That it's not like the Leaning Tower of Pisa or something like that. Okay? And even if it wasn't, technically this is asking how far off the ground is the ladder, and height is always measured at a 90-degree angle. So even if my house is leaning, the height is still going to be measured at a 90-degree angle straight down to the ground. If you fall, you're going to fall straight perpendicular to the ground. Let's not fall off the ladder, though. It's going to be too far for us. Oh, I think. All right. So if I want to know how far off the ground the ladder is, so if I'm standing up here doing something on the ladder, how far off the ground am I? Okay, so that's going to be this length here. Is that length a leg or a hypotenuse?
A leg.
It's a leg. So am I going to add or subtract? Subtract. Which number is going to go in first? 15. Okay, so square root of 15 squared minus 6 squared. When I round this to 3 places, how far off the ground am I? 13.748. I do know my units here. My units are feet. I did say, and then I didn't actually show you, if you put your subtractions backwards, remember it has to be hypotenuse squared minus leg squared. And I told you I'd show you what happens if you put it in backwards. Let's look at what happens if I do 6 squared minus 15 squared. When I put it in backwards, I told you the calculator will tell you that's not right. I get an error for a non-real calculation because you can't take the square root of a negative number in the calculator, right? And if you're subtracting a bigger number from a smaller number, so if you do a little number minus a big number, you get a negative, right? So the calculator tells you that is not a real answer. It's a non-real calculation. The reason they say it that way, a non-real calculation, is because if you haven't taken Algebra 2 yet, if you have, you know why. But when you take Algebra 2, you'll learn about what's called imaginary numbers. So you have non-real, you have imaginary numbers, and you have real numbers, and it gets crazy. It's something to look forward to if you haven't done it yet. Okay? So if you ever get that non-real calculation, you just put your numbers in backwards, redo it, put them in the right order. Okay? Easy peasy. Now, where else can we apply the Pythagorean theorem? You can apply it in an isosceles triangle, even if the isosceles triangle is not right. And the Pythagorean theorem, though, only works in a right triangle. So, just some review, because we haven't talked about isosceles triangle properties since like Thanksgiving. Our altitude in an isosceles triangle from the vertex angle will bisect the vertex angle and the base. So it cuts this angle in half, and it cuts the base in half. Okay? So the reason it's nice to draw the altitude in an isosceles triangle is because I know an altitude starts at a vertex and it ends at a 90-degree angle, so then if I look at just half of that triangle, I can see a right triangle. And a right triangle, I can use Pythagorean theorem. The x in the right triangle, not the x in the whole triangle, but the x in the right triangle, is it a leg or a hypotenuse? It's a leg. So that means I'm going to add or subtract. Subtract. What's my first number? 9 squared. What's my second number?
4 squared.
4, right? It's not going to be that whole 8 all the way across the bottom. It's just going to be half of it, so it's just going to be 4. Don't forget to square it. So, in my calculator, the square root of 9 squared minus 4 squared is 8.062 or 3? 2. 8.062. Okay. All right, the next one. When I do the same thing on the next one, I know I have been bisected here, which means I've been cut in half here. I'm using 2 tick marks this time because I already did 1 tick mark there and there. Each of these are going to be 9. And I really only need to look at one side so that I can apply the Pythagorean theorem to the right triangle. Okay? So am I looking for, is x a leg or a hypotenuse? In this one, it's a hypotenuse, right? Because I have the altitude this time. So am I going to add or subtract? Add. My 2 numbers are 24 squared and 9 squared. So square root of 24 squared minus 9, or plus 9 squared, gives me 25 points. I don't even have to worry about rounding. They've already done it for me. 632. Questions? All right, 2 more. The next one, find the altitude of an isosceles triangle with a base length of 20 centimeters and congruent sides that measure 32 centimeters. All right, so for this one, I don't have a picture. I can sketch it. I know I'm isosceles, so 2 sides are the same. I'm trying to find the altitude. My base length is 20. And the congruent sides are 32. In order to do the Pythagorean theorem, we have to look at just a right triangle. I can't look at the whole isosceles triangle. So if I'm looking at just the right triangle, and I'm trying to find x, am I finding a leg or a hypotenuse? A leg. So am I going to add or subtract? Subtract. What number goes in first? 32. Don't forget to square it. What number goes in second? What is it? 10. Don't forget to divide it in half. Squared. So in my calculator, the square root of 32 squared minus 10 squared is 30.397 or 8? 7, because the 4 doesn't have to bump up. It only bumps up with a 5 or more. So x equals 30.397. I know my units here. What are my units? Centimeters. Anytime you know the units, you should write them. Last but not least, during a severe thunderstorm, a utility pole was struck by lightning and a portion of the pole fell over as shown below. Find the height of the utility pole before it was damaged in the storm. Okay, so I can see a right triangle there, and the side I'm missing, is that a leg or a hypotenuse? It's a hypotenuse. So am I going to add or subtract? I'm going to add. What number goes in first? 8. And then 6. Don't forget to square them. How big is x? It's what? 10. And we know the units, feet, so this must also be feet. So my utility pole was 10 feet tall, yes? The piece that's broken on the ground is 10 feet tall. Find the height of the utility pole before it was damaged in the storm. How tall was the utility pole before it was damaged in the storm? 16 feet. So that's a good example of you needing to read the problem, right? We found the missing side of the triangle, but that's not what this was asking me for. It was asking me to find how tall was the original pole. The original pole was 6 feet, the piece that's still standing, plus the 10 feet that fell over, so it was 16 feet. Okay, important to read. Make sure you know what the question is asking. That's going to be really important on all of your assignment. In your assignment today, It's a Google Sheet or it's a Google slide that you're going to be manipulating for your assignment today.